Hi, welcome back to the session. In this session, we'll be discussing about the mission-dependent loader functions. So there are three categories in that mission-dependent loader functions. As you could see, the relocation, program linking, and algorithm and data structures for linking loader. The relocating loaders will be performing the relocation. As we could see that the program relocation we have seen in the previous session, how the assembler was handling the relocation. If at all there is a relocation, how the assembler gives the information to the loader. That is how we have discussed in the previous session. In the loader part, the relocating loader is going to handle the relocation. If at all there is a relocation, that is the starting address what is mentioned earlier that is going to be changed at the time of load time, then how it is going to handle the situation. That's what by using the two different techniques. There are two methods for mentioning the relocation. One is a modification record, as we have already seen in the previous sessions, and the other one is the relocation bit mask. So what is the idea behind the relocations? Already have told you that since there is a larger memory, so there is a option for many programs to share the same memory location. That's what whatever the memory which is mentioned for the program, which, that cannot be given to the program at the time of loading. So that might be used by some other program. So several programs are being run. So that is the reason why actually the relocation happens. So in that case, if there is a relocation for the different machine for SAC and SACXC, that is the reason why we are discussing about this particular topic in under this machine dependent features of the loader. So one of the important topic in the machine dependent features of a loader is relocation, because depending on the machine, whether it is a simple machine or a complex machine, depending on that it varies. So for the SAC machine, we go with the relocation bit mask. For the SAC-XE machine, the modification record would be used. So we'll see how it exactly that will be used. So for a modification record, it can be used for the complex machines. Complex machines are nothing but the SAC-XE machines. So in which the relocation and linkage directory specification is being used. Say for example, if you look at the modification record, so wherein you could see that relocation address, the address which needs to be changed, which is known as the relocation address, that is in the column, and the next column would be length, which I have already told you in the previous session also. And here the two more columns are added in the modification record with respect to the relocating loader. So the flags plus or minus, whether the next column which represents the segment name, so that is a symbol, whether the symbol has to be added or subtracted, that is mentioned by the flag. So the last column is a segment name. That is what is the symbol which needs to be added. That is given by the last column. Okay. So these are the informations provided in the modification record. And if you could see the simple machine wherein the relocation bit mask will be used. The relocation bit mask, the reason for going with the other technique, that's relocation bit mask, rather than opting modification record. Why actually that is required is, as you have already noticed in SAC and SACXC, when the relocation happens in SAC machine, in lot of places, in many instructions, the object code has to be changed. Whereas in SAC machine, the object code which needs to be changed in very few places. I can say that in SAC the program which we have discussed in the previous session, where around three records were there, the three modification records were there for the object code in SAC. Whereas if you take the SIC machine, in which the direct addressing is being used for most of the instruction. Since the direct addressing is used when there is a program relocation, then most of the instruction need to be changed. In such case, the modification record also to be kept for each and every record. So more instructions that required changes, then more number of modification records should be there in the object program. So the object program size would be more since we are keeping modification record in the object program as a part of the object program. So if you increase the number of modification record for each and every instruction which require changes, then the size of the object program will be more. And obviously it takes the memory also. So that is the reason why actually go with the other method, that is relocation bit mask. It is especially for the SAC machine, that is simple machines. So the reason for opting the relocation bit mask is for because the direct addressing. It is for the simple machine. The relocation bit mask can be used in with the text record. So if you look at the text record format, so there is a change in the text record. So the column 1 denotes T, that is nothing but the text record, and we have the starting address for the particular current text record and the length in for the current text record. Apart from this, we have the column like relocation bits. So there are 3 columns we have for the relocation bits, followed by the object code. So each record can have more than 10 instructions. It can accommodate up to 12 words. So we have 3 columns. Each column will take 4 bits. So 3 columns will be having 12 bits. So 12 bits within 12 bits, we will be able to accommodate 12 instructions. But how we can mention the modification or the changes in this bits are, say for example, if the relocation bit mask which represent the modification, suppose if there is no modification required for that particular object code, means then it will have the value 0. If the bit is having the value 1, then the modification is required for that particular bit. So this is how the different relocation bits will be having the values, so that the loader will understand whether there is a modification required or not. So 0 represent no modification is required, whereas 1 represents modification is required. And it is not that all the 12 object code we are going to keep it in a single text record. Sometimes a single text record can have 10 words, sometimes 12 words or 8 words. It depends. So it is not that all the 12 object code can be there in the single text record. In such situation, say for example, there are 12 bits and we have only 8 object codes in the text record. The remaining places, the remaining bits will be having the value 0. So we can understand that the unused words are also set to 0. It's not only that 0 represent no modification. 0 also represent if there is no object code, then the relocation bit will be 0. So if you would like to change any value in the object code, that will be mentioned among the relocation bits. So these relocation bits are combined together, and it is forming the 3-byte segment. So I can show you the example how the relocation bit mask are used in the text record. So you can see the object program. T denotes the text record, and there are multiple text records we can see. And the text record containing the starting address and the length of the current text record, that is 1E, which I have shown you in the at the time of creating the object program itself. When the assembler generates the object program, how it is looking like, that I have already shown you when the object code creates the when the assembler creates the object program. So the length of the current record, text record, would be there, and after that we have the relocation bit mask. The relocation bit mask will be in the 3 columns. So when you can see the FFC. This is the value which is available in the segment relocation bit mask. So the F denotes the 4 ones, that is 1, 1, 1, 1. And we have one more F also, which is also denoting 1, 1, 1, 1. And C we have it is denoting 1, 1, 0, 0. So each character denotes 4 bits. So totally that there are 12 bits are available. Each takes 4 bits. So 3 characters are there. So it is giving 12 bits. So in this 12 bits, based on the number of words, the number of object code present in the text record, the value would be changed. Now in the first character F, which denotes 1, 1, 1, 1. So which means that all the 4 bits are having the value 1, which means that the first 4 object code which needs modification. So if you look at the object code 140033, 481039, then the 4036, then 280030. So these 4 object code require modification because each bit from the F has the value 1. So 1 represent modification is required. So the modification is required for the first object code, second object code, third object code, and fourth object code. Similarly, the second character F, again it denotes another 4 ones. So again, starting from the 5th, 6th, 7th, 8th, all will be needed to be changed. So all the object code should be changed. Then we have C, that will be having 1, 1, 0, 0. So the last 2, maybe the text record doesn't contain the last 2 object code. So since the object code is not all there, so we can keep the value 0, 0 for the last 2 object codes. So since it can accommodate 12, so only we have 10 object code in this current text record. So the last 2 doesn't have the object code at all. So we will be keeping the 0, 0 value. So this is how it has been used. Same way for the each individual text record which is having the relocation bit mask. This is how the relocation bit mask will tell you whether it require a modification or it doesn't require any modification. So there are 2 ways in which the relocation can be used. So which can be used by the relocating loaders. So when the loader is being called, so it might use the 2 different techniques with respect to the machine what we have chosen. So whether it is SAC machine or SAC XC machine, based on which it holds the technique. Moving on to the second feature, that is program linking. Okay, so program linking, before moving into that, the program linking is part of the loader and linker. So when you have the loader and linker, most of the loaders which includes the linker, I have already mentioned this point, most of the loaders which includes the linker, so it does the linking, relocation, and as well as loading. So that is the reason when I started with this module, I was telling you there are three functions which we have in the loaders and linker. Those are relocation, linking, and loading, allocation and loading. So the programming linking, which tells you that so the linking happens between the object program. So whenever there is a external symbols which is referred, the symbols are referred from other program to our program. So that time how it is going to resolve the external symbols, that is what is dealt in the program linking. So the program linking, it resolves the problem with the EXTREF and EXTDEF. The EXTREF and EXTDEF from the different control section, as we use this EXTDEF and EXTREF in the control section. So the control section is nothing but we have a program that will be divided, or that will be separated into different control section. Each control section will be considered as a separate program unit. So each control sections can assemble, can load, can execute at a different time. So what happens here is, when you have the EXTDF and EXTREF, so these are the two assembly directives which are used in the control sections. When we use these two assembly directives in the control sections, which represent the external references. So when you have this EXTDF and EXTREF in your control section or in your program, so how it is going to be used, or how it is bringing the concept of external symbols, that I'll give you with an example. Let us say, so this is one program, say program A. Okay, so we have one more program, program B, and the last one, it is a program C. So we have three programs, three control sections we have. And if you could see program A, wherein I told you EXTDF and EXTREF. So EXTDF is nothing but the symbols which are defined in this control section. Say the control section is program A. In program A, we use, or we define the two symbols, list A and end A. So the same symbols can be used by some other program. So we have the definition for list A and end A in this control section, and these symbols can be used by some other program, might be program B and program C. And if you look at the EXTREF, so we have some other symbols like list B, end B, list C, and end C. So these are the symbols which we refer, which means these are the symbols which we use in this control section, but the definition would be available somewhere else. So might be the list B and end B. Definitions of these two symbols would be available in program B. And list C and end C, these symbols would be defined in program C. So these symbols are defined somewhere else, but we use it in this control section, that is program A. If you look at program B, you can make out that EXTDF, we have list B and end B. EXTREF, we have list A, NDA, list C, and end C. Now look at the program C. EXTDF, we have list C and end C. So list C and end C are defined here, but you use this list C and end C in program A or program B. Similarly, EXTREF, list A, NDA, list B, end B, these are defined in program A and program B, but it is used in program C. That's the difference. So you have three programs. So program A, program B, and program C. Now, if you take list A and the NDA, these symbols are defined in the different location. Say 0040. In that location, list A is defined. 0054, in this location, NDA is defined. So we have the definition for list A and NDA in program A. But we don't have the definition for list B, end B, list C, and end C. Now, moving on to the program B, we have list B and end B, which are defined in program B. Say, for example, in 0060, list B is defined. In 0070, end B is defined. So these are all defined in program B, but used by program A and program C. Even here also we can use the symbols, but if you are using, there is no problem. EXTDF, list C, end C. So in the location 0030, list C is defined. In the location 0042, end C is defined. Now I'll go back to the program A. Let us take one example. Let us take REF4, which is in the address 0054. So when you see this REF4, this is the label. And we have the opcode word. And in the operand field, we have NDA minus list A plus list C. So we have NDA minus list A plus list C. So this is the expression we have. So we can have expression that can be assigned that constant from the evaluation of expression can be assigned to the label. Say REF4 is the label for which what is the result which comes out of this expression will be assigned to this label. As you know that the word, opcode word, which is used to generate the integer constant. So how we get the integer constant? We are not directly keeping the integer. In some places you could have seen in the previous programs, some value would be there and 3 zeros, we will be keeping the constants. But here instead of constant, what we keep is the expression. So what is the expression we are having? NDA minus list A plus list C. So when you evaluate this expression, what is the result come? That result is being assigned to the REF4. That is the meaning of this instruction. Now, so this is the program. This can be given to the assembler for processing so that the assembler generates object code. But we are in the loader and linker loading and linking process. So wherein the linking has to happen, then it is given to the loader for the further processing. So as you could have seen, we are discussing about the program linking and how the linking happens. That is what exactly we would like to know. Now, so if you take the NDA minus list A plus list C, so what happens? We have to evaluate the expression, right? Now, in the SAC or SACXC machine, when there is a constant, so what we have done for the object code generation, so what we understood for the object code generation, whatever the constant, same thing will be there for the object code. Since there is an expression, what is the result comes out of this expression, that will be the object code, right? Now, when you see the expression, we have some symbols. What are the symbols? We have list A, NDA, and list C. As you know, list A and NDA are defined in this control section. As I have already told you that the control section will be assembled load at different time. When you process this program A, so when the assembler do the assembly process for this particular program, that is control section, program A, that time the program B and program C need not be assembled. So, what is the value which is there in the program B and program C? Which means what are the symbols are defined in program B and program C that we do not know. So that is the reason here, if you look at the expression NDA minus list A plus list C, as you could make out that the list A and NDA are defined here. Since it is defined here, obviously we will be able to know the value of list A and NDA. So what can be the value of list A? What is the address where it is defined? That address we consider as a value over here. So normally the target address we take it. So the list A where it is defined and the NDA where it is defined, that is the address of the target. So we consider those. Now where the NDA is defined, which is defined in the location 0054. And where the list A is defined, it is defined in the location 0040. And what is the value of list C? So list C is not defined here. List C is not defined here. So we don't know the value of list C. You remember in pass 1 and pass 2 algorithm, when I was explaining about the pass 1 and pass 2 algorithm, if there is an undefined symbol, if there is an undefined symbol, what is the operand address for that symbol? What is the operand address for the symbol? Please keep thinking. We will discuss this in the next session.